what's the format of the data transfer instruction and what's the meaning of L, B and W, and we discussed about quite a few examples related to data transfer instruction. That is how to move data from a register to register, register to memory, memory to register, all the possible combinations we discussed and we studied. Okay, and then we discussed about what is segment register and how many bit is a segment register, what is general purpose register, how many bit is a general purpose register, how many general purpose registers are there, all the things we discussed. And it's good to see so many people are responding. And I got so many WhatsApp messages stating that they tried and they got this error or they are not able to get it because of this issue. So it's good to see that people are showing interest to learn the subject. And another thing is they are showing interest to do the things by themselves. That is a very great thing. Yeah, it's nice to see. And how many of you had installed the tool, installed VirtualBox and the Ubuntu? Can you please raise the hand, participants? How many of you had installed the tool and install the Ubuntu image? Participants, yes, 1, 2, 3, 4, 5. Oh my God, only 5. But I got more than 10 WhatsApp messages, at least by the name looks like they are from section B. Only I could see 1, 2, 3, 4, 5, 6 hands. Rest all are yet to install, is it? Why you people are taking so much time? At least okay. Slowly I'm getting a response. 8, 9, 10. Good. Yes. At least I can see 1/4 of the class. Good. Okay. I got from quite a few students. They attempted the program lab 1 and they were asking for some doubts also. They are from section C. That much I know with their name and I can see them here. So it's good and nice to see everybody started working on it. Yes, if you are having any doubts, you can ask me in the class or you can send a WhatsApp message. If I didn't respond on, maybe sometimes I won't see, either in the morning or in the night only I'll check. That's my time to check the WhatsApp messages. So if I see 100%, I'll respond. Okay. So start solving. Any doubts you can ask me. And next thing is, as I already told, there are 3 types of instructions. Good. You can lower your hands. There are 3 types of instruction. One is data processing, next is data transfer, third one is conditional instructions. First is data transfer instruction we studied. Okay. In today's class we are going to discuss about data processing instruction. Okay. And another thing, this data transfer, data processing, conditional instruction, all the instructions are part of the theory syllabus. Okay. Course content, there is 1 chapter. In that chapter these 3 instruction types are there. So theory also we are, this is the theory for the lab thing. Okay, what we are doing in the lab, for that associated theory is there in the theory course content. That one we are discussing in the class. Okay, so in today's class we are going to discuss about data processing instruction. So as the name shows, we are going to process the data. Processing in the sense we are going to perform either arithmetic operation or logical operation. That is the processing. means. So we know the different types of arithmetic operations and we know the different type of logical operations. In today's class we are going to discuss about how to write the instruction for the arithmetic operation and what is the format of arithmetic operation and what is the name of arithmetic instruction, and next we will discuss about what is the format of logical instruction, what is the name of logical instruction. Okay, and we'll discuss about which logical instruction to use under which context. All the things we are going to discuss in today's class. At least today and the next class we will discuss these things. Data processing instruction. Okay. So I repeat, data processing is to process the data. Data processing instruction performs arithmetic and logical operations. In today's class we are going to discuss about this. So what are all the arithmetic operation you know? Neharaj, Neharaj. Neharaj, is there anyone with the name Neharaj? SBNN, that's a name I can see in the window, but I don't know the person's name. Can you please unmute yourself and answer to the question? What are all the different?
Yes, ma'am.
Yes, yes. What's your name? Neha.
Neha Raj.
Neha Raj. Okay. What are the different arithmetic operations you know, Neha? Arithmetic operations. Arithmetic operations.
Addition, subtraction.
Yes, good. Very good.
Multiplication, division.
Yes, very good. These four are the arithmetic operations. Addition, subtraction, multiplication, division. Okay, good. You can mute. Okay, today's class we are going to discuss about the format of the addition instruction, subtract instruction, multiplication instruction and division instruction. Okay, so first we will discuss about addition instruction. The name of the instruction name for the addition operation is the ADD. Okay, the instruction name is ADD. That is the instruction name. That is add. Add is the instruction name and it takes the specifier L, B and W. Okay, as we all know, L is for 32-bit, B is for 8-bit, W is for 16-bit. Okay, so the format of the instruction is add followed by L or B or W space source comma destination. Okay, so now I'll show the PPT. Okay, so they are able to see the PPT now? Are you able to see the PPT?
Yes, ma'am.
Yes, fine. So now first instruction I'll take ADD-B. So ADD stands for add instruction. B is nothing but we are going to perform add instruction on a 8-bit value. Okay, B stands for 8-bit, right? And
excuse me, ma'am.
Yes.
Sorry to interrupt, but can you record the meeting?
Okay.
Because it
So
will be easier for us to download it.
Yes, fine. But the problem is, okay, after downloading it, whether it will get deleted. They are saying there is a problem.
It will get
It
will get deleted within 20 days.
Within 20 days, okay. Because once we asked, today morning also in section A, they are saying this, like they want the video to be recorded. So when class to be recorded, when I checked with the IT people, they are saying there is a storage issue. So I don't know and I'm yet to talk to them, but no problem. Today I'll record, but after that I'll check with them. If they are okay, I'll record all the sessions. Okay?
Okay, ma'am.
Yeah, it started. So now you can see that the ADD is the name of the instruction and B stands for it is to do 8-bit operation followed by source comma destination. Okay, and in this instruction the source value is $10. Okay, the source value is $10 and the destination value is percentage of AL. And the meaning of the instruction is the instruction is going to perform add operation on a 8-bit value. Okay, and here the source is going to get added with the destination. Okay, anything, if you want to perform add operation, we need two operands. The first operand is the source, that is value 10. And where is the second operand? The second operand is nothing but this AL register works as a second operand as well as the destination. Okay, so the meaning of the instruction is the value in the register AL is added with the value 10 and the result is stored in the AL register. That is the meaning of this instruction. Okay, it adds the immediate value 10 to the 8-bit register AL. Okay, and the next instruction if you take, it is ADDW space percentage of BX comma percentage of CX. Okay, so the meaning of the instruction is ADD stands for add, W is nothing but 16-bit. So the 16-bit value is added. So what is the source and what is the destination? Because we know that the meaning of add instruction is the source will be added to the destination register. Okay, so the source in the given instruction is percentage of BX and the destination is percentage of CX. So the value in the BS register is added to the CS register and the result is stored in the CX register. That is the meaning of this. Okay, and the next instruction is add L data comma percentage of EAX. As I already told, ADD first is the instruction name, ADD is the instruction name, L is for 32-bit. So the meaning is the 32-bit value of the source is going to get added with the destination and the result will be stored in the destination. And in the given instruction, the source is the data, so the value of the memory location data is added with the destination. The destination is nothing but EAX register. So the value in the data is added with the value in the EAX register and the result is stored in the EAX register. That is the meaning of this instruction. And we'll go to the last instruction, that is add L percentage of EAX comma percentage of EAX. The meaning is add, L stands for 32-bit, source is EAX, destination is EAX. So the value in the EAX register is added to EAX register and it is stored in the EAX register. That is the meaning of it. Okay, so I repeat, the instruction format for the add instruction is, first we have to give the instruction name. After that we have to write whether it is for the operation is for 8-bit or 16-bit or 32-bit, that is L or B or W, and next we have to give the source comma destination, and the meaning is the source value is added to the destination. Okay, that is the meaning of the instruction. Okay, so we are done with the add instruction. And the next thing what we are going to do is we are going to discuss about the next arithmetic operation, that is the subtract instruction. Okay, so the subtract instruction, the name of the instruction is SUB. Okay, SUB stands for subtract, that is the name of the instruction. And after SUB, we have to give the specifier. Either it can be L or it can be B or it can be W based on the operation what we are going to do. And percentage of EAX comma percentage of EBX. So now what is the meaning of this is, so first you have to write what is the source here. The source is, first is the source which is EAX register. And next you have to write what is the destination. The destination is the second one, that is EBX register. Okay, and next we have to write what is the meaning of the instruction. SUB stands for subtract. So the meaning of the instruction is the source value is subtracted from the destination. Please be clear. The source value is getting subtracted from the destination. So what is the source here? EAX. What is the destination? EBX. So we are going to subtract the source from the destination. Okay, and the result will be stored in the destination. That is very important. Okay, so the result is stored in the destination. So the meaning of this is the value in the EAX register is subtracted from the value in the EBX register, and the result will be stored in the EBX register. Okay, so I repeat, subtract instruction, whatever the arithmetic operation we take, it needs two operands. Both are the source. But now, and we have to store the result in destination. So basically we need three things. But the instruction format permitted only two operands, one source and one destination. So what is happening here is the destination act as one of the source. Okay, so now the meaning of the subtract instruction is the whatever the value we are giving in the source is subtracted from the destination and the result is stored in the destination register. Okay, and next I'll write one more instruction, SUBL $100 from percentage of ESI. Can anyone please explain me what is the meaning of this instruction? SUBL $100. Yes. Yes.
Doubt. I had a
Yes. Yes.
doubt. Before we move, this is ESI is not possible
ESI is not possible. Why?
because it's a source index, right?
No, we can use it, no problem. ESI register value, it's 0 only. We cannot use ESP, stack pointer. Rest all the registers we can use.
Okay. Also, ma'am, can the registers store negative values?
Yes. You can see the negative values when you are storing it. You can see that 2's complement representation of negative values. It is possible. I'll show the demo. You know 2's complement representation, right? If you don't know, also no problem. We will discuss what is 2's complement representation. In 2's complement representation, all the negative values are stored that you can see when you are giving info registers. It is possible. Yes, next question. Yes, next question. What's the question?
No, ma'am, I'm clear.
Okay. You are Mahadev, right?
Oh, yeah.
Okay, fine. Yeah, anyone please, what's the answer for this SUBL $100, percentage of ESI? At least in that class, I know some people. 1 second. Sadhana, roll number 105. That day I didn't call you, no? Sadhana, roll number 105.
Yes, ma'am.
What is the meaning of this instruction, Sadhana? SUBL $100, percentage of ESI. SUB stands for what?
Subtract
Very good. L stands for?
32-bit value,
Okay. What is the source here, Sadhana?
$100,
Yes. What's the
and
destination here?
ESI register.
ESI register. So what is the meaning of the instruction?
So you subtract 100 values from the destination and the value is stored in the destination.
Yes. So the meaning is this. The value 100 is subtracted from the value
From
presented in
ESI.
yes?
Yeah, 100 is subtracted from the value in ESI and it's stored in ESI.
Yes, very good, very good. Thank you so much. The value 100 is subtracted. That's the source is subtracted from the destination. That is the value 100 is subtracted from the ESI register and it is stored in the ESI register. That is the meaning of this instruction. Now next, one second, SUBB. Percentage of AL, comma, data. Can anyone please explain the meaning of this instruction? SUBB, percentage of AL, comma, data. Roll number 108. That day I didn't call this roll number. Sanath. Two Sanaths are there. Sanath. 108. What's your name? 108. Yes, Sanath.
Yes, ma'am.
Can you explain this instruction? SUBB, percentage of AL, comma, data. Can you explain this instruction?
Subtract, ma'am. SUB.
Subtract. SUB stands for subtract. Okay. What's the meaning of B?
B is 8-bit.
Very good. After that, we had given percentage of AL. What is percentage of AL here? It is a
register.
Okay, it is a register. Whether it is source or destination?
Source.
Very good. What is the destination here?
Data.
Data is the destination. Now you have to tell me what is the meaning of the instruction. Like before this instruction I had written, for the previous instruction, whatever is getting highlighted, the same way now you have to answer to the instruction, to this instruction. SUBB, percentage of AL, comma, data. What is the answer for this? You have to. Sanath?
Yes, ma'am.
What
data
first?
is equal to?
Yes, good. Data equal to, data is the destination. Destination equal to?
Data minus?
Data minus?
I guess AL.
AL. Okay. So the value of the source, that is the AL, is subtracted from the destination, that is the data. So the value present in the variable name data, that is, with that value, this AL value will get subtracted and then the result is stored in the data. Okay, that is the meaning. Yes, done. Very good. Thank you, Sanath. Okay, so first we discussed about add instruction and add instruction format, and next we discussed about subtract instruction and subtract instruction format. And the next what we are going to discuss is about the multiply instruction, and then we'll discuss about the format of multiply instruction, and then we'll finally we'll discuss about division and the format of division instruction. Okay, so all these things are very, very important. Please remember this instruction name, at least instruction name, nobody will get confused, because for addition it is ADD, for subtraction it is SUB, for multiplication it is MUL. That is the first 3 letters of the operation, so it will be easy for you to remember. Okay, and the next very, very important thing what we are going to discuss is the multiplication instruction. As I already told, all the arithmetic operation needs 2 operands, right? 2 source and 1 is the destination. At least for addition and subtraction, we got the assembler had given as 2 things, like 2 registers or 2 inputs we can give, one for the source and one for the destination. But when you check the format of multiply instruction, it is the multiply instruction takes only 1 operand as the input, that is the source. Okay, we can give the source, one of the source as the input to the multiply instruction. Okay, we don't know how to give the second input, we don't know what could be the destination also. Okay, but that assembler supports the multiply instruction to takes only 1 input. Okay, that is the source. So first I'll take one example and then I'll explain you how the instruction is doing the operation. Let us take the number 12 into 35. Okay. So first we'll discuss about how to perform this multiplication. As I already told, multiplication takes only one number as a input. Okay. So where that another input will get stored. So the another input will get stored in the EAX register. By default, one of the input of the multiply instruction will be in the EAX register. I repeat, multiply instruction, one of the input will be in the EAX register. Similarly, the result will be stored in the EAX register. Okay, one input will be stored in the EAX register and the result also will be stored in the EAX register. Okay, and we have to store the another input value in any registers, okay, other than ESP, stack pointer register. We can store it in any registers. So in this example, I moved the value 12 to the ECX register and I moved the value 35 to the EAX register. After that multiplication instruction I called, MUL stands for multiplication, and then ECX, as I already told, it takes only one value. So what is the meaning of this is, the value in the EAX register is multiplied with ECX register and the result will stored in the EAX register. That is the meaning of it. Okay, the value in the EAX register is multiplied with the source given in the instruction, that is ECX, and the result is stored in the EAX register. Okay, so if the result is 16-bit value, we all know if we multiply two 8-bit numbers, we will get a 16-bit number as a result. If the result is a 16-bit number, then the result will be stored in the register AX. Okay, if the result is a 16-bit number, if the result is 16-bit number, then it will stored in the AX register. If the result is 32-bit number, if we multiply two 16-bit numbers, you will get a 32-bit number as a result, correct? If you multiply two 8-bit numbers, you will get a 16-bit number as a result. If you multiply two 16-bit numbers, you will get a 32-bit number as a result. So in which register it will get stored is, it will get stored in DX AX pair. Okay, so why we can, there is a 32-bit register named EAX, then we can store it in EAX register. No, why we are not storing it in EAX register? The meaning of this is to maintain the compatibility. From the beginning I am saying, no, there is two concepts. One is computer architecture, another one is computer organization. Architecture is it's about instruction set architecture and how a programmer sees a computer. And from the beginning, people want to maintain the same architecture concepts, that is same instructions with the minimal changes. All the computers are following the same architecture concepts. The difference comes in the organization part, that is what are the components and how it is getting connected. All those things are the organization part that is getting differed. But only one thing is, we want the architecture to be the same. So to maintain the compatibility with the first generation computers, people are still following this format, because that time we had only 16-bit registers. We didn't have 32-bit registers. So that is the reason they used two 16-bit registers to store a 32-bit number. So this AX register contains the value from 0 to 15. And DX register contains the value from 16 to 31. Okay. Similarly, if we multiply two 32-bit numbers, what will be the result? The result will be how many bits? If we multiply two 32-bit numbers, the result will be how many bits? To the maximum of 64-bit. Okay. If the result is a 64-bit number, then it will get stored in which register? Any guess? It will get stored in which register? Look at the answer for the result of 32-bit number. Now you can say the answer for a 64-bit number. So which register it will get stored? Anyone? The answer is yes, EDX, very good. EDX, EAX pair. Okay, EDX, EAX pair. EAX contain the bits from 0 to 31 and EDX contain the bits from 32 to 63. Okay, so this is the meaning. The result is a 64-bit number, then it will get stored like this, EDX, EAX pair. Okay, so multiplication instruction takes only one operand as an input. The another operand is EAX register. Similarly, the destination is also EAX register. Okay, so now whatever the value we are giving as an input is multiplied with the EAX register and the result will be stored in the EAX register. That is the meaning. Okay. So any doubt in the multiplication instruction? I'll write few more instructions. MULL data. So what is the meaning of this? Anyone? MULL data. What is the meaning of this? The value in the data is multiplied with the register EAX and the result is also stored to EAX register. The meaning of this is the value in the memory location data is multiplied with the EAX register and the result is also stored in the EAX register. If it is 32-bit result, it will get stored in EAX register. If the result is 64-bit, it will get stored in EAX EDX pair. Okay. So the meaning of this is EAX into data. That is the meaning. Okay. So next is MULB. So what is the meaning of this? What is the meaning of this? What's the meaning of this? Again, I have to call someone. Roll number 82, Parikshit. Roll number 82. 82 is sleeping. 82 is not available. Okay. Naveen Kumar, roll number 76. That day also I called, he didn't respond. Roll number 76, Naveen Kumar. Okay, Naveen Kumar is sleeping, absent. Roll number 90, Priyanka Kumari. Priyanka Kumari. Yes, Priyanka, can you please explain the instruction MULB percentage of CL? What is MUL, Priyanka?
Ma'am, I don't know the answer.
You don't know the answer. Okay, at least what is the meaning of MUL? Priyanka is not listening, I guess.
Yeah, ma'am, I'm listening.
Okay. What is MUL stands for, Priyanka?
Mul B and
Okay, next question you have to answer. Okay, no problem.
okay, ma'am.
Dikshita, roll number 92, Dikshita.
Yes, ma'am.
Dikshita, can you please explain me this instruction and the answer means what's the meaning of the instruction?
Yes, ma'am. A value from CL register
Yes.
is multiplied with a value in EAX register.
Very good.
And is stored in the EAX register.
Yes, very good. EAX, but as I already told, there is a small mistake in this. If we multiply two 8-bit register, what will be the result we will get? If
32-bit.
Two 8-bit means
Oh, sorry, 16-bit.
16-bit, right? So
Yes,
the name of the 16-bit is AX, correct? So the answer will be AX equal to CL multiplied by AL. Okay, that's the answer. Correct, no? Because when we multiply two 8-bit register, you will get a 16-bit register as a result. Correct? So AX equal to CL into AL. That's the meaning of this instruction. Okay, good. The next. So you are clear in add instruction, mul instruction, subtract instruction, right? The next what we are going to discuss is the division instruction. Okay. So the division instruction, we know that it takes two things. One is dividend, next one is divisor. But the division instruction takes divisor as one of the input. Okay. Then what happened to the dividend? That is stored in the EAX register. Okay, so as I already told, the multiplication and division takes only one operand. One is the multiplication, one is the source. For the division, it takes divisor. Okay, so I'll take one example to explain the things. Suppose the question is 12 divided by 2. Here the dividend is 12 and the divisor is 2. Okay, so first instruction, that is one of the operand has to be in EAX register and another operand has to be in any register whichever we want. So move L, I am moving, okay, there is one mistake I did, this has to be dollar, and move L $2 to let us say I am moving to ESI some value. Okay, so now when we are using div L, so we have to give our divisor, whatever the results that is having our divisor as a input to the division instruction. Okay, so that is nothing but ESI. And we all know that the division gives two results, right? What are all the results that is provided by the division operation? Division operation will give two results, right? So what are the two results that division operation provides? Answer please. What are all the two results that division operation provides?
Quotient, remainder.
Yes, quotient and remainder. So our quotient is very, very important. That is stored in the EAX register and the remainder will be stored in EDX register. So I write quotient will be stored in EAX register and the remainder will be stored in EDX register. Okay. So in division, one of the operands has to be in EAX, same as that of multiplication, and the result also, that is the quotient portion of the result, will be stored in EAX. Okay, this is also same as that of multiplication. Only difference is we are getting one more result, that is nothing but our remainder that is stored in EDX register. Okay, so for division operation, quotient will be in EAX register, remainder will be in EDX register. Okay, so now our division operation is also done. Okay, so in what do you have to do in day 2 lab is you have to, I'll give one instructions, or I'll give a statement. You have to use all these 4 instructions to perform the operation: addition, subtraction, multiplication, division. And the next thing is there is one more operations called logical operations. There in the next class we will discuss about what is logical operation and what are all the logical operations available and how many operators or operands it will take. Okay, all the things we will discuss in next class. Okay, so now I'll ask anyone to paraphrase what I did in today's class. Can anyone explain about add and subtract instruction, at least paraphrase it? Divya, Sai Divya Sri, 110. Sai Divya Sri, what are all the arithmetic operations we studied today?
Addition, subtraction, multiplication, division.
Very good. What is the format of add instruction?
Add, specify LBW, comma,
Okay.
source, destination.
Source, comma, destination. Yes. What is the format of subtract instruction?
Subtract, LBW, source, comma, destination.
Subtract LRBRW, source, comma, destination. So what is the meaning of the subtract instruction?
Source value is getting subtracted from destination value.
Yes, very good. The
And
value
it's stored in destination.
Yes, the value of the source is subtracted from the destination and it is stored in the destination. Yes. And next, what is the format of multiplication instruction?
Multiplication, LRBRW, source, comma, destination.
Source, comma, destination.
Only source, only source.
Only source. So where is the another source and what's the destination value? Both are stored in which register? Huh?
Both are stored in EAX register.
Yes, very good. Both are stored in EAX register. Okay. And format of division?
Division, LRBRW, source.
DIV, and then divisor. Okay. So where our quotient will get stored, where remainder will get stored?
Quotient is stored in EX and remainder EDX.
EDX. Okay. Very good. Very good. Thank you, Divya. Thank you so much. Yeah. See, today we studied all these arithmetic instructions. The 4 instructions we studied: add, sub, mul and div. Okay. And there are other formats also like add with carry, add with overflow. All the things are there. But slowly we will discuss all the things. Okay. In for arithmetic operations class, this much is enough. After that we'll get into if carry comes, what do we have to do? Like if we are adding 2 8-bit numbers, if we are getting one 9th digit, that's extra value, what do we have to do with that? How to check that values? All the things we will discuss maybe after doing one more lab. Okay. So first you have to get familiar with this arithmetic instructions and then logical instruction. After that we'll discuss about what to do with these things. Okay. So addition and subtraction instruction takes 2 operands, source, comma, destination, but multiplication will take source as the input, division will take divisor as the input. By default, one of the input and the result will be stored in EAX register for multiplication and division operation. Okay. So this is for the today's class, and we are done with arithmetic operation. We'll meet tomorrow. What time is our class tomorrow? Tomorrow is Tuesday.
11.
Right? Yes, 11:15. Right. So we'll meet tomorrow 11:15 to discuss the another set of instructions. Are you able to understand? Are you started feeling comfortable with assembly language programming? Nobody is responding. Okay, at least we'll see. And another thing, our lab is on Friday. As I already told, I need the lab document for the lab 1. The document should have 5 screenshots, because I started getting messages, madam, do we have to write aim, do we have to write objectives? Nothing is there. Already I had shared the manual. In that manual, lab 1 is there. In that lab 1, what are all, there are 6 subsections is given. What do you have to do is, first screenshot is the program for the lab 1. And the second screenshot is take any one instruction. Before executing the instruction, what is the status of the register? That is screenshot 2. After executing the instruction, what is the status of the register? That is screenshot 3. Screenshot 4 is again take one more instruction. What is the status of the register before executing it, and what is the status of the register after executing it? That is screenshot 4 and screenshot 5. Okay, so totally I need 5 screenshots, and you have to share your screen, and based on this your document I will ask the questions. Okay, your questions will be like how many general purpose registers are there, whether it is 32-bit or 16-bit. If it is 32-bit, what is the name of the registers? 8 registers you have to tell. If it is 16-bit, what is the name of the register? It is AX, BX, CX, DX. If it is 8-bit, AL, AH, BL, BH, like that. How many segment registers are there, what name them, whether we can edit the value of segment registers, and control registers, it is used by processor, what can it is editable by the user, and then a few more questions related to your document what you are submitting. Okay, so these are all the questions that I will ask for the as a viva, and based on the viva I'll evaluate you, and immediately maybe by the end of that lab, first lab, I'll share the marks. Okay, like for all the 10 labs I'll take viva, that is for 20 marks. Totally it is 200 marks. This 200 marks will be scaled down to 25, that is your internal marks. If you are doing well, you will get 20 out of 20. If you are able to answer for all the questions, you will get 20 out of 20. Okay. If you are not performing well, based on your performance, your mark will get reduced. Okay. So at least try to prepare from lab 1. Okay. And the questions, if you are not able to note down what the questions that I said, open the session 1 PPT. Session 1 PPT I had shared. No, it is there in the group. Open the session 1 PPT, run through it. Okay. So whatever the questions I'll ask are from the session 1 PPTs. Okay. Okay, done. Thank you all. Thank you all. See you tomorrow.